Hi there, I'm Sridhar Chandrasekaran, and I'm presenting a study series on power transmission line construction. Drawing from my extensive career experience, this series is designed to provide practical and theoretical insights that can be directly applied to real-world projects. The primary goal of this study is to help engineers and managers deepen their understanding of transmission line construction, enhance the quality and efficiency of their work, take accountability and ownership of the tasks they manage. We began this journey by exploring the basics of electricity, how it's generated, its requirements, and its sources. From there, we've covered critical stages such as tendering, bidding, and project initiation. Moving forward, we'll delve into implementation, execution, and finally, project handover. Given the complexity of this topic, the content is divided into chapters released weekly. Along the way, we'll also integrate discussions on essential complementary areas, including engineering ethics, legal considerations, health and safety compliance, human resource management. These vital aspects will be seamlessly woven into our technical discussions to provide a holistic perspective. Each week, I'll release a new video featuring key technical topics, ethical dilemmas and considerations, a thought-provoking quote to inspire meaningful reflection. Currently, we're in Chapter 11. Trying to understand the construction activities, there's still so much more to discover, so stay tuned for the upcoming chapters. Thank you for joining me on this journey of learning and growth. Disclaimer. Just a quick note. The content in these videos is meant for informational and basic educational purposes only. These videos aren't intended to provide professional advice or endorsements. This helps set the right expectations about the nature of what we're sharing, especially since we draw on material from various sources under the principle of fair use. From this chapter, we will explore the full range of construction activities and their corresponding procedures, subsequent a valid sequence from start to finish. Each task will flow seamlessly into the next, ensuring a smooth and efficient progression throughout the construction phase. In our previous chapters on project management, we discussed the procedures and steps necessary to initiate a project. Now, building on that base, we will move forward with the construction phase. In this section, we will delve into the practical application of what we covered in project management, providing a detailed explanation of how these concepts are implemented during the construction activities. 1. Site handing over. 2. Survey. 3. Coordinate system, GEIOD, ellipsoid. 4. Bush clearing, tree cutting and access road. 5. Soil investigation. 6. Foundation. 7. Tower erection. 8. Stringing. 9. Checking and energizing. In this chapter, we will begin by focusing on site handover and part of the survey process. Let us start with the detailed steps involved in site handover before progressing to the survey phase. Before any site activities can commence, the contractor must have access to the entire line route, or at least a portion of it, free from right-of-way issues. The consultant engineer or the client has to issue a formal site handover letter to the contractor granting permission to begin work on the designated section of the project. Procedure for requesting right-of-way clearance by the contractor. Before the contractor can begin any construction activities on a transmission line project, it is essential to secure right-of-way ROW clearance for the land along the designated line route. This clearance is critical to ensure that the contractor has legal access to the land without obstacles such as buildings, vegetation, or legal disputes. A. Contractor's request for right-of-way clearance. B. Consultant engineer's role in issuing site clearance. Let us understand first, Part A. Contractor's request for right-of-way clearance. The contractor must formally request right-of-way clearance from the consulting engineer or client before starting any site activities. This request typically follows a structured procedure to ensure that all necessary information is provided for the consultant's review and approval. Step 1. submission of right-of-way clearance request. Step 2, submission of survey and site preparation documents. Step 3, follow-up and site visit request. Step 1, submission of right-of-way clearance request. The contractor prepares and submits a formal right-of-way clearance request letter to the consulting engineer. This request must include detailed information about the segment or section of the transmission line for which clearance is required. The request should cover the specific section of the line, example, tower numbers or kilometer markers, the intended start date of site activities, any documentation regarding land acquisition, if applicable, such as proof of compensation to landowners or agreements with local authorities, a plan indicating the sequence of construction and the portion of the line requiring immediate clearance. Step 2, submission of route survey and site preparation documents. Along with the right-of-way clearance request, the contractor should submit survey documents and site preparation details, including these should verify that the alignment of route has been correctly marked, details of the land showing that the area is suitable for construction, a document outlining the access roads and corridors to be used by construction teams. Step 3, follow-up and site visit request. The contractor may also request a joint site visit with the consulting engineer to physically inspect the right-of-way and ensure that there are no obstacles, example, buildings, vegetation, or local objections preventing work. This helps in identifying any on-site issues before clearance is granted. Supporting documents required from contractor: survey maps and line profile, detailed route maps showing the alignment of the transmission line, land acquisition or compensation agreements, proof that compensation for land use has been paid where necessary, environmental clearances, if applicable, any environmental impact assessments or permits that are needed for right-of-way clearance. Work schedule, a proposed construction schedule indicating when the contractor intends to start work in the cleared area. Now let us venture in Part B of site handing over. Consultant engineer's role in issuing site clearance. Once the contractor submits the right-of-way clearance request, the consulting engineer follows a standard procedure to review and process the request. The consulting engineer's role is crucial to ensure that the requested right-of-way is fully cleared of any legal, environmental, or physical obstacles, and that the land is ready for construction activities. 1. Review of the contractor's submission. 2. Verification of right-of-way status. 3. Site inspection. 4. Issuance of site clearance intimation. 5. Monitoring and follow-up. 6. Possible conditions or restrictions in the site clearance. 7. Key documents issued by the consultant engineer. 8. Challenges during right-of-way clearance. Step 1. Review of the contractor's submission. The consulting engineer first reviews all the documents submitted by the contractor, ensuring that the request is complete and all necessary clearances, such as land acquisition agreements and environmental permits, are in place. Step 2. Verification of right-of-way status. The consultant will verify the status of the right-of-way to ensure that it is free of obstructions. This includes confirming that landowners have been compensated or agreements have been signed for access, ensuring that the land is free from any legal disputes or objections from local communities, verifying that any trees, structures, or vegetation that would obstruct the line's construction have been cleared or will be cleared in a planned manner.
Step 3. Site inspection. The consulting engineer may conduct a site visit, often jointly with the contractor, to physically inspect the requested section of the row. During this inspection, the consultant will check alignment and marking of the transmission line route, availability of access roads for construction equipment and materials, presence of any obstacles, such as unremoved structures, trees, or terrain issues that could impede work. Site preparation and compliance with environmental and safety standards. Step 4. Issuance of site clearance intimation. Once the consulting engineer is satisfied that the requested right-of-way section is clear and ready for construction, they will issue a formal site clearance intimation or site handover letter to the contractor. This document officially grants the contractor permission to begin work in the cleared area. Site clearance letter contents. Specific details of the section being cleared, tower numbers, kilometer markers. Date of clearance. Any special conditions or limitations, for example, environmental restrictions, safety requirements. Confirmation that the right-of-way is free of obstacles and the contractor has the right to commence construction. Step 5. Monitoring and follow-up. After issuing the clearance, the consulting engineer may conduct periodic follow-up inspections to ensure that the contractor adheres to any conditions outlined in the clearance letter and that no new obstacles arise during construction. Step 6. Possible conditions or restrictions in the site clearance. Environmental restrictions. The contractor may need to take specific environmental protection measures, such as erosion control or limiting work during certain seasons. Safety requirements. The consultant may impose safety regulations that need to be adhered to during the construction process, such as fencing or warning signs. Partial clearance. In some cases, the consultant may grant clearance only for part of the line, with additional right-of-way sections to be cleared later. Step 7. Key documents issued by the consultant engineer. Site clearance letter. The official document granting the contractor access to begin construction in the cleared right-of-way section. Joint site inspection report. If a site visit was conducted, a report documenting the findings and verifying that the site is ready for construction. Row clearance certificate. If required, the consultant may issue a right-of-way clearance certificate confirming the right-of-way's readiness for construction after verifying compliance with all necessary conditions. Step 8. Challenges during right-of-way clearance. Landowner disputes. In some cases, disputes with landowners may delay right-of-way clearance, requiring intervention from local authorities or further negotiations. Environmental concerns. Delays in securing environmental permits or completing assessments could affect the issuance of right-of-way clearance. Incomplete surveys. Errors or omissions in the initial route survey can cause delays, requiring resurveys or adjustments in the route. With this, we have come to an end of topic site handing over. Before starting the most important activity in transmission line construction, I would like to explain how this activity is managed and controlled in the modern world, including the systems used for operation, monitoring, and documentation. To fully understand this process, it is essential to learn about the development of the Geographic Coordinate System, GCS. The Geographic Coordinate System is a fundamental tool used for accurately representing positions on Earth. It is based on the concepts of latitude and longitude, which are expressed using angular units and derived from mathematical models like the ellipsoid. Understanding how these components interact is crucial for effective mapping, navigation, and spatial analysis. This topic is very important for understanding how the survey system functions in transmission line projects. Since it's a vast subject, I plan to cover this topic in greater detail in our later chapters, once we complete the survey activity. So now let us start our second chapter in line construction, survey. This topic shall be covered in 3 chapters. So let us commence with understanding about survey. Survey process in transmission line projects. Once the site clearance is received and access to the line route is granted, the contractor can deploy the survey team to verify the route based on the coordinates provided by the client. The survey is a crucial phase that ensures the alignment of the transmission line is feasible for construction and free from obstructions. Below is a detailed explanation of the various types of surveys conducted, their purposes, and the associated forms and activities. A. Route survey. B. Detail survey. C. Profiling, submission, and approval. D. Check survey. E. Cross-diagonal profile. F. Geographic coordinate system. In this chapter, we will explore only route and detail survey, and the balanced topics we will understand in upcoming chapters. Route survey. Let us first understand what exactly is a route survey. Route survey in transmission line construction is the process of determining the most suitable path for a transmission line. It involves collecting topographical, geographical, and environmental data along the proposed route. The goal is to identify a route that minimizes environmental impact, avoids obstacles like rivers and urban areas, and ensures cost-effectiveness. Conducting a route survey for a transmission line involves a meticulous process to ensure the alignment and feasibility of the proposed route. This begins with aligning the entire line route according to the provided geographic coordinates, which are typically based on preliminary design or planning. Using GPS and mapping tools, surveyors ensure the planned path adheres closely to these specifications. A. Route confirmation. B. Reporting hindrances. C. Clearing hindrances. D. Route submission. E. Approval. Route confirmation. Mostly, the route is determined by the client based on their needs and requirements, with approvals obtained from various departments as discussed in earlier chapters. The contractor is required to adhere to this route unless significant obstructions necessitate changes. During the bidding phase, the contractor evaluates costs based on the route provided by the client. Should changes arise during the construction phase, the contractor is eligible to amend their costs, a topic we will explore further in later chapters. Once the route is provided by the client, the contractor's survey team conducts fieldwork to gather critical data along the specified route. This data includes key details about crossings, for example, roads, railways, rivers, low-profile landscapes, for example, valleys or dips affecting line tension and clearance, aviation zones, restricted areas due to flight paths, existing structures or features impacting construction or safety. Surveyors also verify the position of all angle points, locations where the transmission line changes direction. These verifications ensure proper positioning relative to terrain, soil stability, and accessibility for construction activities. As the survey progresses, the team inspects the route for unforeseen hindrances or obstacles not addressed in the initial design. Examples of potential obstacles include forested areas, government or military lands, habitations or densely populated areas, wildlife sanctuaries, challenging terrains, for example, hilly, swampy areas or wide rivers, air zones or restricted airspace. If major obstacles are encountered that cannot be easily resolved, alternative alignments may be proposed. This involves careful evaluation to maintain project efficiency, minimize costs, and comply with environmental and regulatory guidelines while ensuring the transmission line's integrity and safety. Reporting hindrances. When the survey team identifies any issues or obstacles along the transmission line route, they promptly document and report these findings to the project team to ensure a swift resolution. This reporting process begins with clearly identifying the nature of the hindrance, such as physical barriers. Example, newly constructed buildings, water bodies, or dense vegetation. Regulatory constraints. Example, restricted zones like wildlife sanctuaries or aviation paths, or unforeseen challenges like unstable terrain or cultural heritage sites. The survey team provides a detailed report which includes the exact coordinates of the identified obstacles using GPS or mapping tools, a comprehensive description of the issue explaining its impact on the project. For instance, they may note how the obstacle affects construction timelines, safety, or route feasibility. Visual documentation, such as photographs, sketches, or maps, to offer clarity on the severity and specifics of the hindrance. Once this information is submitted, The project engineers analyze the reported issues and prepare a formal communication for the consultant and client engineers. This written correspondence outlines the following: the type and nature of the hindrance. Example, encroachments, environmental sensitivities, or technical challenges. The urgency of addressing the issue, specifying whether it requires immediate intervention to prevent delays in subsequent phases. Propose solutions or recommendations, such as altering the route, obtaining necessary clearances, or coordinating with local authorities for mitigation. Supporting documents, including the survey team's report, visual evidence, and route maps, to substantiate the claim. The formal submission ensures that all stakeholders are informed and enables the consultant and client engineers to initiate necessary actions. This might involve securing approvals, coordinating with local agencies, or revising the project design. Prompt communication and documentation help maintain project momentum while addressing obstacles effectively and professionally. Clearing hindrances. Clearing hindrances is a critical step to ensure smooth progress after obstacles are identified during the route survey. Once the contractor submits a detailed report on the hindrance, the consultant and client engineers arrange a joint site visit to thoroughly assess the situation. This visit allows them to understand the exact nature of the problem, evaluate its impact on the project, and determine the most practical and cost-effective solution. Exploring and implementing solutions. The approach to resolving hindrances depends on the type and severity of the issue. Engaging with the local community. If the hindrance involves land disputes, encroachments, or local opposition, the consultant and client engineers take steps to engage with the affected community. They may hold discussions or mediation sessions to understand community concerns and work towards mutually agreeable resolutions. Compensation. The project team may offer compensation to landowners or residents for the inconvenience caused or for acquiring the required land. Compensation packages are tailored to the demands and expectations of the local stakeholders, ensuring fairness and compliance with legal standards. Awareness campaigns, in some cases, educating the local community about the benefits of the project. Example, improved infrastructure, economic development, or employment opportunities, may help ease resistance. Obtaining government approvals. For hindrances that involve regulatory or legal constraints, the project team collaborates with relevant government agencies to secure the necessary clearances. For example, in restricted zones like forests, aviation paths, or near protected heritage sites, special permissions may be required. If the issue involves safety concerns, such as unstable terrain or proximity to sensitive installations, appropriate mitigation measures are developed in consultation with authorities. Ministry or police support in cases where legal or enforcement action is required. Example, resolving land ownership disputes, addressing illegal encroachments, or managing protests. The ministry provides assistance to the client. This might involve coordinating with police or other enforcement bodies to ensure a peaceful and lawful resolution. Adjusting the route. If the identified hindrance proves to be unresolvable despite efforts to mediate or obtain permissions, the client and consultant engineers may recommend adjusting the transmission line route. This involves rerouting the line to avoid the obstacle while minimizing additional costs and delays. Ensuring that any new alignment remains compliant with technical and regulatory requirements and does not create new challenges. Coordinating with the contractor to revise construction plans accordingly. By ensuring a structured approach, throughout the process, all actions and decisions are documented meticulously, including the rationale for the chosen solution, approvals obtained, and any adjustments made to the project plan. The ultimate goal is to resolve hindrances efficiently while maintaining project integrity, minimizing delays, and ensuring stakeholder satisfaction. Route submission marks a critical milestone in the survey and planning phase of a transmission line project. Once all identified hindrances have been cleared or addressed, the survey team undertakes the task of preparing and submitting a finalized route map for approval. This process ensures that the planned transmission line route is practical, feasible, and compliant with all technical, environmental, and regulatory requirements. Steps in route submission. Preparation of the cleared route map. After resolving hindrances, the survey team compiles all route data and creates a detailed topographic map. This map clearly outlines the finalized route with all geographic coordinates accurately plotted. Additional information included on the map may feature important features such as crossing points, terrain details, nearby infrastructure, and areas of environmental or regulatory significance. Along with the map, the team prepares a comprehensive report documenting the hindrances faced, the solutions implemented, and any changes made to the original route alignment. A soft copy of the map and associated data, example, GIS files, is also generated for electronic review and analysis. Submission to the consultant engineer. The cleared route map, along with all supporting documentation, is submitted to the consultant engineer, CE, for review. The CE acts as a key intermediary between the contractor and the client, ensuring that the route meets technical and regulatory standards. Verification and inspection. Upon receiving the route submission, the CE team begins the verification process. This includes both a physical inspection of the route and an electronic review using GIS software or digital tools to validate the accuracy of the coordinates and alignment. During the physical inspection, the CE team, often accompanied by representatives of the client, visits critical points along the route to ensure that the ground conditions align with the submitted map and that all reported hindrances have been resolved. This dual inspection process helps identify any discrepancies or oversights in the submission. Approval of the route. If the route is found to be accurate and fully cleared, the consultant engineer provides full approval. This approval signifies that the route is ready for the next phase of the project, such as detailed design or construction. In cases where certain portions of the route still have unresolved issues, example, pending land clearances, unresolved disputes, or regulatory delays, the CE and the client may issue a partial approval. This allows work to proceed on the cleared sections, while efforts continue to resolve the remaining obstacles. The unresolved sections are flagged in the approval documents, along with specific actions or deadlines for their resolution. Any feedback or requests for modifications from the CE or client are communicated back to the survey team. The survey team may be required to revisit the site, update the map, or make necessary adjustments to ensure compliance before final approval is granted. Detailed survey. A detailed survey is an essential step conducted after the approval of a transmission line route. The primary objective of this survey is to collect accurate and comprehensive data about the terrain, environmental conditions, and potential challenges along the route. This information is vital for ensuring the design, planning, and construction phases of the project proceed smoothly and efficiently. A well-executed survey minimizes risks, optimizes project costs, and ensures the stability and reliability of the transmission line. The survey addresses all factors influencing the feasibility of the route and ensures they are well documented. It can be conducted using various methods based on the specific project requirements, including the conventional manual method, aerial LiDAR, and ground LiDAR. Each method offers unique advantages and is selected based on the project's scale, complexity, and terrain. The detailed survey focuses on several key aspects as outlined below. A. Fixing of alignment. B. Fixing of angles of deviation, fixing of angle points. D. Fixing of direction points. E. Levels at regular intervals. F. Details of road and villages. G. Crossings, corridor detailing along the line. I. Cross-diagonal detailing in hilly areas. J. River flooding areas and water reservoirs. K. Settlements and agricultural land. L. Forests and vegetation. M. Landslide-prone zones. N. Land settlement zones. O. Other influencing factors. Deliverables of the detailed survey. Fixing of alignment. Fixing of alignment. The exact alignment of the transmission line is determined and finalized based on the approved route and terrain conditions. This process ensures the road avoids obstacles like buildings, water bodies, or restricted zones while adhering to regulatory and technical requirements. Alignment fixes the overall path of the transmission line, which serves as the foundation for further design work. Fixing of angles of deviation. Angles of deviation, where the line changes direction, are calculated and marked. These points are critical as they determine the structural design of the towers, which must bear extra mechanical stress. Proper determination of deviation angles ensures the line's mechanical stability and avoids unnecessary strain on towers. Fixing of angle points. Angle points are marked along the route to finalize the locations where the direction changes. This ensures proper alignment and spacing between sections of the transmission line, minimizing the need for rerouting or design adjustments. Fixing of direction points. Intermediate direction points are identified to guide the straight sections of the line. These points help maintain the alignment and ensure that the line runs smoothly between angle points, especially in areas with irregular terrain or vegetation. Levels at regular intervals. Ground levels are recorded at regular intervals, typically every 10 to 20 meters, depending on the terrain's complexity. In hilly or uneven regions, closer intervals are used to capture changes in elevation more accurately. These level measurements are crucial for calculating tower heights, sag tension values, and maintaining the required ground clearance. Details of road and villages. The survey identifies all roads and villages along the route to plan access for construction and maintenance. Proximity to villages is noted to minimize disruption to communities, while road details help optimize logistics for material transportation. Identification of crossings. Power line crossings, identifying existing overhead lines to plan safe clearances and prevent interference. Railway crossings, noting all railway crossings for planning permissions and designing adequate safety measures. River crossings, determining river widths, flow conditions, and flood levels to design appropriate structures and mitigate risks. Corridor detailing along the line. A detailed mapping of the corridor surrounding the transmission line is conducted. This includes identifying vegetation, man-made structures, and any obstacles within the corridor that may require clearing or special attention during construction. This ensures compliance with safety and regulatory standards. Cross-diagonal detailing in hilly areas. In hilly or mountainous regions, cross-diagonal alignments are documented to account for zigzag patterns often required for stability. These details are crucial for designing towers that can accommodate steep slopes and uneven terrain. River flooding areas and water reservoirs. Flood-prone zones and water reservoirs along the route are mapped to prevent potential risks to the line and towers. Towers in such areas are designed with higher foundations to withstand flooding or waterlogging. Settlements and agricultural land. The proximity of the route to residential settlements and agricultural land is documented. This helps minimize displacement and crop damage while ensuring compliance with social and environmental regulations. Forests and vegetation. Forested areas and dense vegetation along the route are identified to plan for clearing and obtaining the necessary environmental clearances. Efforts are made to minimize the environmental impact, often by rerouting the line around protected zones or implementing compensatory afforestation. Landslide-prone zones. Areas prone to landslides, especially in hilly regions, are identified and flagged for special design considerations. Towers in these zones may require additional stabilization measures, such as anchor foundations or retaining walls. Land settlement zones. Zones where the land is prone to gradual sinking or settlement are documented. This ensures tower foundations are designed to withstand such conditions, preventing structural issues in the future. Other influencing factors. Any additional factors that may impact the feasibility, stability, or safety of the line are noted. Example S includes seismic activity, groundwater levels, extreme weather conditions, or proximity to industrial zones. Deliverables of the detailed survey. Once the survey team completes the detailed fieldwork and gathers all relevant data, the next step is to submit this information to the design team or the Power Line Systems (PLS) team. This team uses advanced tools such as PLS-KD, computer-aided design and drafting, to create transmission line profiles, finalize tower spotting, and develop the technical design parameters necessary for construction. Here's an expanded explanation of the entire process. The survey team compiles and organizes all collected data into a structured format for easy reference and analysis by the design team. The submitted data includes topographic details, precise terrain elevations, slopes, and features, coordinates, latitude and longitude of alignment points, angle points, and crossings, geological and soil data, soil type, bearing capacity, and conditions affecting foundation design, environmental data, vegetation, forest areas, water bodies, and flood-prone zones. Crossing details, dimensions and clearance requirements for crossings such as roads, railways, rivers, and power lines. Meteorological data, wind speed, temperature variations, and weather conditions along the route. This data ensures that the design is tailored to the specific physical and environmental conditions of the project site. In this chapter, we began with site handover and covered essential topics related to the survey, including the rote survey and detailed survey. This has provided a strong, foundational understanding of these key areas. In the next chapter, we will continue by exploring the remaining survey activities to build a more comprehensive understanding of the entire survey process. With this, we have concluded our technical study. Now, let's transition into our next topic on legal compliance. In our study program, we have consistently emphasized the principles of professional ethics, covering all related topics in previous chapters. We have also introduced the subject of legal compliance and plan to explore additional areas, including human resources, HR, and health, safety, and environment, HSE, in future chapters. Today, as a continuation, we will delve into legal compliance in corporate business for professionals and staff. This new topic aims to provide valuable insights, and we hope it will be beneficial for all our viewers. Legal compliance refers to the adherence to laws, regulations, standards, and ethical practices that govern corporate activities. For corporate professionals, understanding and following these requirements is essential for maintaining the integrity, reputation, and success of both the individual and the organization. Legal compliance is a critical component in corporate governance and business operations, helping professionals navigate complex regulatory environments, avoid legal issues, and ensure ethical business practices. Let us understand the aspects of legal compliance for corporate professionals. These are following topics we will be covering in our chapters. 1. Relevant laws and regulations. 2. Corporate governance and ethical standards. 3. Compliance with employment laws. 4. Data privacy and protection. 5. Anti-corruption and anti-bribery laws. All these topics we have already covered. Today we will cover topic No environmental compliance. And in our upcoming chapters, we will cover the following points: financial and tax compliance, intellectual property compliance, implementing legal compliance in the workplace. Environmental compliance in transmission line construction ensures that all project activities align with environmental laws, regulations, and standards to minimize the project's impact on the environment. This involves several critical aspects. 1. Environmental impact assessment, a detailed study conducted to assess the potential environmental impacts of the transmission line project. It evaluates effects on land, water, air, wildlife, vegetation, and nearby communities. Mitigation measures are proposed to reduce negative environmental impacts. 2. Obtaining environmental permits. Mandatory permits from environmental authorities must be obtained before starting construction. Permits may include forest clearances, water usage permits, and wildlife clearances, depending on the terrain and project scope. 3. Right-of-way and land use management ensures proper clearance is taken for accessing land and minimizes disturbance to ecosystems, forests, and agricultural areas. Plans are developed to avoid sensitive zones like wetlands, wildlife sanctuaries, or protected areas. 4. Waste and pollution management. Proper disposal of construction waste, hazardous materials, and chemicals. Dust and noise pollution are controlled through mitigation measures during construction. 5. Biodiversity conservation. Implementing strategies to protect wildlife habitats, flora, and fauna affected by the project, avoiding construction during breeding seasons in sensitive areas. 6. Soil and water conservation. Erosion control methods, proper drainage systems, and measures to protect water bodies from contamination. 7. Compliance monitoring and reporting. Regular environmental monitoring during construction to ensure compliance. Submission of reports to environmental regulatory authorities for verification. 8. Rehabilitation and restoration. Post-construction, restoring disturbed land and planting vegetation where required. Compliance with reforestation obligations if trees were cleared during construction. Importance of environmental compliance. Prevents legal penalties and project delays. Protects the ecosystem and local communities. Enhances corporate social responsibility and sustainability efforts. Environmental compliance ensures that transmission line construction is sustainable, legally sound, and environmentally responsible. Today's quote is from Thomas Alva Edison. Our greatest weakness lies in giving up. The most certain way to succeed is always to try just one more time. This quote emphasizes the importance of persistence and resilience. It suggests that giving up is our greatest obstacle to success. Many people fail not because they lack ability, but because they stop trying when faced with challenges. The quote encourages pushing forward and making one more effort, as success often comes after overcoming repeated failures. By continuing to try, even when things are difficult, we increase our chances of achieving our goals.
As we wrap up our session, I encourage you to subscribe and hit the bell icon so you won't miss any of our upcoming chapters. It's your gateway to mastering transmission line supervision.
That concludes Chapter 11 for today, where we explored site handing over and key aspects of the survey process. In the next chapter, we'll continue delving into the remaining topics on survey work, with this subject extending over the next few chapters. Until then, take care and thank you for tuning in.